Lesson 4, permutations when objects are distinguishable. So when you have a distinguishable object, say for example the digits 0 through 9, so everything in that set of numbers is a different thing. So you're given a ballot to vote for school council, and there are 5 people on the ballot, and the positions are vice president, president, treasurer, secretary, and social coordinator. So we have president, VP, treasurer, secretary, social coordinator. How many different ways can you fill the ballot out if you vote for all 5 positions? So if you're going to vote for all 5 positions, there's 5 times 4 times 3 times 2 times 1. You can do 5 factorial ways. So 5 times 4 times 3 times 2 times 1 is 120. So that's if you vote for all of them. If you just wanted to vote for president, VP, treasurer, and secretary, so we're only going to vote for 4 of them. So we have 5 people to vote for here, 4 people to vote for here, 3 people to vote for here, and 2 people to vote for here. We're not voting for the last person. So we have 5 times 4 times 3 times 2. We're not doing the 1, which is 120 ways. Another way to write this is if we were to look at 5 factorial, we want to get rid of that last factorial, so we would divide by 1. So because it's 1, it doesn't really matter. We know that that's how it works. But that is how you get rid of the 1. If we only wanted to vote for 3 of the positions, president, VP, and treasurer, we would vote for 5 times 4 times 3. So it would be 5 times 4 times 3, which is 60 different ways. Another way we can write this is 5 times 4 times 3 times 2 times 1. We want to get rid of the 2 and the 1. And the way that we could get rid of the 2 and the 1 is we could take 5 minus 3 factorial. And notice that we're choosing 3 people. We're only voting for 3 people. So if you notice the pattern, it'll help us get to the formula. The next one, we're only choosing the president and the vice president, so there's 5 and 4 ways, which is 20. So that's the same as 5 times 4 times 3 times 2 times 1 factorial. We want to get rid of 5 minus 2 factorial, because we want to get rid of 3 factorial. And that would leave us with 5 times 4. So notice that the number we subtract from 5 is how many objects we're choosing. So for the last one, if we wanted to vote for just the president, there'd be 5 ways to do it. So 5 times 4 times 3 times 2 times 1. We want to get rid of 5 minus 1 factorial, which is 4 factorial. So this and this will be canceled, and we'll be left with 5. So when we are writing an expression to show the number of ways to vote, you take the number that you're factorialing, so n factorial, and you're going to divide by n minus however many you're choosing. So n is equal to the number of options, and r is the number you're choosing, you're selecting. So NPR is when you're doing a permutation. You're choosing from a distinguishable amount of objects. So a permutation is when the order matters. N is how many objects there are in total, the total set of different objects. And R is the things you're using in the arrangement. And we can use the formula n factorial divided by n minus r factorial to solve for permutations. So for example 2, Matt has downloaded 10 new songs from iTunes to make a playlist arranged in any order. How many different 6-song playlists can he create from these new songs? So we have 10 songs. He's going to choose 6 of them. So we're going to rewrite this in factorial notation. So we have 10 factorial divided by 10 minus 6 factorial, which is the same as 10 factorial divided by 4 factorial. We can cancel this to be 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. The 4's will cancel, and if you type that into your calculator, you should get 151,200. So that's how many different playlists he could make from those 10 songs. Another way that you can type this into your calculator is there is a button that looks like this. It's a permutation button. If you type 10p6, you will get 151,600. You should be able to show it by canceling out with factorial notation, but you can check with the calculator, and sometimes it is much faster to use the calculator. On my calculator, it's second function 6 to find that button. So part B, if he makes 7, 8, and 9 song playlists, how many ways can he make each of these? What do you notice as each of the playlists get closer to 10? So we're going to do 10, choose, or pick 7. Usually use the word pick for permutations. 10, pick 8, 10, pick 9, and 10, pick 10. Also keep in mind that if he was to just use all 10 songs, we would do 10 factorial. So 10 pick 7 when typed into your calculator is 604,800. 10 pick 8 is 1,814,400. 10 pick 9 is 3,628,800, which is the same as 10 factorial. And 10 pick 10 is 3,628,800. So as you get bigger and closer to your maximum, there's only going to be so many ways. So 10 pick 9 and 10 pick 10 are the exact same number because there's only a certain amount of orders in which you can choose objects. So getting bigger towards the number you picked gets you closer to that number as a factorial. So we're going to use the formula to show that 0 factorial is the same as 1. So we're going to let n equal 10. So if we have 10 and we pick 0, that means that there's 1 objects. So I know our n is equal to 10, our r is equal to 0. So if we plug this into the formula, n factorial over n minus r factorial, we have 10 factorial divided by 10 minus 0 factorial, which is the same as 10 factorial over 10 factorial, which is 1. So no matter what you picked for n, you'll always get it back to be 1. So 0 factorial is always equal to 1. This is the end of a proof.